Hi everyone, my name is Jeff Wallace and I'm talking about AWS Lambda. So just to go over the agenda first, I'm going to give an introduction to what AWS Lambda is and some motivating use cases. Then I'm going to talk about its architecture, and specifically looking at the capabilities it offers and its pricing. And we're going to take a look at a hands-on demo at the AWS Lambda console and create a sample hello world Lambda function. Then we'll look at a real world application of AWS Lambda and close with a summary. So first, just looking at the introduction to AWS Lambda. So just an overview of what Lambda actually is. It is a serverless compute platform as a service offering from Amazon and their Amazon Web Services. By serverless compute, I mean that it is abstracting away the actual management of the server and allows you to really just focus on writing your code and not needing any of the infrastructure or worrying about any of the infrastructure needed. So it is similar to what we looked at other platform as a service offerings like Elastic Beanstalk. However, it's even more removed because it doesn't actually create EC2 instances or anything like that for you. You really just focus on on what the code is, and that's really it. It's also highly available and scalable due to a continuous scaling paradigm, and I'll discuss more about what I mean by that in a second. It's a little bit different from auto scaling as we've seen it, although it's a similar concept. And it's a natural choice for data processing applications, but it can also be used as a back-end service for Internet of Things devices or web applications and things like that. So how it works is you write what's called a Lambda function, hence the name AWS Lambda, which is written in one of several supported languages. I think currently Lambda supports Python, JavaScript, C#, Java, and Amazon's always looking to add more language support to services like these. So I would expect to see more additional languages being supported in the future. And kind of the key point of Lambda is that you get to configure events or triggers that will invoke your Lambda function in response to some event, whether it be an event from another Amazon service like S3, Kinesis, which is an Amazon service to process or help you process and stream real-time data, or DynamoDB, which is a NoSQL database offering from Amazon that we didn't look at it too much detail in the course, but we did briefly mention it. It could also be an event triggered from an HTTP endpoint. So, for example, a user goes to a specific URL or hits a REST API in your application, and that triggers your Lambda function to run. Or in addition, you can programmatically use in one of the Amazon APIs to trigger based on some custom logic in your application. And the key point here, and this is going to go back to that idea of continuous scaling, is that Lambda runs your code only in response to a trigger. And so it is continuously scaled in the sense that you never have to worry about what machine your code is running on. You just know, and Lambda provides the guarantee that when some event triggers that, if a trigger goes off that you have configured, your Lambda function will run. So you don't have to worry about any of the scaling of your instances. You don't even have to really worry about the idea of instances. You don't know what machine this function is running on, but it's continuously scaled because every time this trigger occurs, a new invocation of the function happens, and so you don't have to worry about uh, the ability for a specific instance to manage a certain number of uh, requests or triggers at a time, because your Lambda function will run each instance or each time a trigger is triggered. So now looking at just some sample use cases. And these are taken from the Lambda documentation on the AWS website. So here's an example of resizing photos, which we'll see later as well. But say you take some picture and then it's uploaded to an Amazon S3 bucket. You can configure S3 to trigger AWS Lambda. So now the act of uploading a picture to S3, Lambda gets a notification and runs some configurable code that you provide that resizes that code or resizes that image. And that image is then resized into whatever formats you need and maybe placed back in a different S3 bucket or published somewhere else. Another use case, and this is this previous use case, resizing photos, is more of a data processing application. And as I mentioned, you can also have some back-end service architecture as well. So this is a use case of that, showing a serverless architecture. So in this situation, you have a website being hosted in S3 into a weather website, and when the user clicks on a link to get weather information, the app makes an API call to a specific endpoint, which triggers Lambda. Lambda then goes interacts with DynamoDB to retrieve weather information, returns it back to Lambda, which returns it back through the gateway to respond to the API call with the weather information. These are two sample use cases. And I just want to mention these are actual real-world use cases. So if you go to the AWS website and look up Lambda, you'll see these two use cases along with several others, and they're tied to actually specific companies. It's showing they're trying to feature how certain companies are actually using this in the real world. So these are real-world use cases, and we'll be simulating one of these later on. Now taking a closer look at the architecture of Lambda. So Lambda has a bunch of different capabilities, and I'm just going to talk about each of these briefly. So Lambda functions is the first one. We've already seen what a Lambda function is. You get to focus just on your code and what application needs to be done there. You can store several different Lambda functions and configure them to be triggered accordingly. Next, you can extend behavior of other Amazon Web Services. So, for example, by hooking up, an S3 bucket or Kinesis or DynamoDB, and having Lambda trigger off events from those applications, you can actually extend their behavior. For example, back to that sample use case of the S3 bucket, you can extend S3 to be not only a media or a medium for storing pictures, but it can also be a medium that automatically resizes pictures for you. Next is bring your own code. So there are actually several different ways, and we'll see this later on in the hands-on demo, that you can implement your Lambda function. The Lambda console provides a cloud IDE, so you can actually develop your Lambda function directly in the Lambda console, or you can develop it yourself on your own machine and upload your code and your Lambda function to the Lambda console. So you have two different ways to bring your own code. Next is automated administration. So this is a really nice thing about Lambda, is that you don't need to worry about any of the underlying instances or whether the load balancer is working, You don't need to even worry about configuring auto-scale settings. All of that is taken care of for you because of this um, nice continuous scaling paradigm. Next is built-in fault tolerance. So what that means is if something goes wrong, that's all right. Your Lambda function will exit gracefully. You can configure timeouts for how long your Lambda function can run. So if it's running longer than it should, it can automatically be terminated by the Lambda service. Of course, like most AWS services, there's ample amounts of logging and metrics that are being collected for you to determine what went wrong if something did go wrong. Next is continuous scaling. So this is, again, we've already hit on this, but it's the idea that you don't even have to worry about auto scaling or making sure your application scales. You write this one nice function that does exactly what you need it to do, and Lambda takes care of the rest because that function gets invoked on every trigger. And you don't need to worry about making sure your application fits into servers or scaling up either horizontally or vertically, in EC2 instances, because you're not even concerned about the instances. AWS Lambda figures out where to run your code. You're just providing the code that needs to be run. The next capability I want to talk about is Lambda at Edge. And this is a really interesting concept where you can configure your Lambda functions excuse me, to specifically run on CloudFront Edge servers to get really low latency responses to your users. For example, if you have a Lambda function that is dealing with CDN content or something like that. This is a really nice way that you can specifically ask for this Lambda function to be run on Amazon's Edge servers to get really low latency responses back to the users. Next is Lambda function orchestration. So you can have several Lambda functions that maybe work together or create a pipeline of processing that you may need. So Lambda provides a way for you to orchestrate multiple Lambda functions in complex configurations to achieve the processing you need. This includes, you can have multiple Lambda functions run in parallel. They can run sequentially or some combination thereof. Next, Lambda has an integrated security model. So as we saw last week in the lectures, Amazon Web Services has a great foundation of security that you can build off of, and Lambda is no different. So your your Lambda functions will be run in a secure environment that Amazon manages for you, and because you're not dealing with instances, specific instances, or specific other resources, because Lambda abstracts all that away for you, you don't really have too many security controls to concern yourself with. That is more on Amazon. Amazon takes more of the burden. Amazon Web Services takes more of the burden in the Lambda service than maybe it would in EC2 or S3 or some of their other offerings. So this service allows you to put more of the security burden on AWS, and again, just focus more on your code and the application business logic there. Finally, you can there's ample configuration options for you to configure how much memory your process needs, your Lambda function needs, how much, what the timeout should be, and things like that. And we'll see more of that configuration as we move into the hands-on demo. Additionally, two things I want to briefly mention before we get into the hands-on demo is the ability that Lambda provides you to reuse other people's Lambda functions. So the Lambda service has two mechanisms to do this. One is called blueprints, where they're basically templates that either are curated by Amazon or other people have created and published that are starting points for you for your Lambda function. So they'll do things like have correct triggers to connect with other Amazon services, and potentially are pulling in certain dependencies that your Amazon or your Lambda function may need to do its job. So for example, if you're doing some image processing, maybe there's a blueprint that will pull in OpenCV or some other image processing library. And then there's also the second mechanism, are pre-configured applications. So if there's a specific, like an end-to-end application that a user or Amazon has developed and published, that you can take and then just configure for your own needs. For example, maybe you're changing the S3 buckets that it's talking to, or setting up your application API endpoints, and the rest just works because it's already a complete application that you just configure how you want it. So we'll see those as we move into the hands-on demo in just a few minutes. So looking at the pricing model, this is another thing that is pretty unique to AWS Lambda. They have a pay-per-use model, which means you're billed for each invocation of a Lambda function, which each invocation is called a request. So you're billed per each request. You're also billed per this metric called memory duration, gigabyte seconds. That sounds complicated, but what it really means is that you're billed for the duration that your Lambda function runs in increments of 100 milliseconds, and your price will go up depending on how much your price per second will go up based on how much memory you have allocated to your Lambda function. So they wrap this up in a nice metric called gigabyte seconds. And the other key point here is that if your function is not running, there's no cost. So there's no cost to store your Lambda function, no cost to create a Lambda function. You're only billed for invocations, requests, that is, and duration of the time, the amount of time your Lambda function is running, and that price is scaled on the amount of memory you have allocated to your Lambda function. Lambda does have a free tier, so the first 1 million requests per month are free, along with the first 400,000 gigabyte seconds per month. So those are pretty generous. It's a pretty generous free tier in Lambda. If you move beyond the free tier allocations in a month, you're looking at you're looking at exactly 20 cents, excuse me, per million requests, and just a fraction of a cent per gigabyte second. So it can be a very cost-effective service and way of doing implementing your application. All right, so now we're going to look at the hands-on demo. So move here, and just to show you what the home page looks like, you just go to your services, go to Lambda. This will bring you to the Lambda console. So I have this existing function here called resizer. I'm going to we're going to hold off on that. We'll come back to that later. Instead, we're going to create a new function. And here you can see these blueprints and pre-configured or pre-built applications that I talked about earlier. However, we're going to just start from scratch with a simple hello world. So when you create a function, you have to give it a name. So we're going to call it hello. And you need to select a runtime. And this may remind you of when we looked at Elastic Beanstalk, where you had to configure what platform you're running on. Here, it's even simpler in some ways. You don't need to worry about not only a language but a application environment. Here, we're really just writing code, and that's it. So we don't even need to worry about, for example, something like Tomcat, right? Like we did in the Elastic Beanstalk example in the course. If you're writing in Java, you really just need to know, hey, I'm writing in Java, and that's it. For this example, I want to use Python. And then you need to select a role, which defines the permissions of your function and what it can do, what it can interact with. And this is managed, these roles are managed by the identity and access management function, like we saw this week as well. So I'm going to use an existing role called JustRole, which has basically no permissions because it really doesn't need to do too much for this hello world example. We're going to go ahead and create the function, and it's going to take us to the page for our function called hello. So you can see here we're on the configuration tab, which allows us to configure and manage our Lambda function. So in this nice designer tool, you can see all of the kind of the pre-built triggers that you can use to configure events that will trigger your application to run. For this particular example, we're not going to have any triggers. We're just going to trigger it manually, just to give you an idea of what it looks like. So you can see here that you can then go down to this function code section, and this goes back to what I was talking about, that the Lambda console provides you a cloud IDE that you can actually use to develop your Lambda function. If you don't want to do that, you can also just upload a zip file, but we're not going to do that here. We're just going to implement it right in the cloud IDE. So you can see here, there's not a whole lot that's going on. It's just returning a nice status code and a body, and this will be turned into JSON and will be sent as the response to the Lambda request. So I'm just going to say, instead of hello from Lambda, hello world, and that's it. And we're going to move down. You can configure environment variables that can be accessible from your function. We're going to skip that now. You also tags. We're going to, like many other services and resources in AWS, you can tag your Lambda function. So we're going to give it a tag just to demonstrate it. You can now toggle that execution role if you desire, but we're okay with this Jeff's role as we talked about before. And then you go to your basic settings, and this is kind of the configuration, resource configuration I was talking about. So you can provide a description, say a hello world Lambda function. You can select the amount of memory, and you're given CPU proportional to the memory configured. We don't need a whole lot of memory here, so we're going to leave it at the smallest block you can, which is 128 megs. And you can configure this timeout, and for our purposes 3 seconds is just fine, because you look back up here, not doing anything complicated, just returning a status and a short message. Going back to that error handling, this is the nice thing that you can you can retry failed executions, or you can forward payloads to an SQS or SNS topic. This goes back to that fault tolerance that we briefly talked about in the capabilities. This gives you a better idea of what you could do. Additionally, one thing I forgot to mention when we were talking about the security, one thing you can control, and one of the few things that you may need to control, is which VPC, virtual private cloud, your function can access. So if you had resources that you wanted your Lambda function to interact with, and those resources were within a VPC, you would want to make sure that your Lambda function was configured to run in that VPC as well. So we're going to go, and you see it says we have unsaved changes. So we changed the code. We haven't saved it yet. So we're just going to go ahead and save. And that's it. It's now ready to go. Because we don't have any triggers, we're just going to manually test it, and Lambda gives you this nice test capability right here. So we don't depend on any input in particular, so our Lambda function, because we're just responding with a status message. So we're going to leave this by the default. But you could change this if you needed to have some specific data pass as a test event, and you actually save these test events as well. So if you have specific use cases that you want to test, that your Lambda function should be able to handle, well, here you go. You can create your 10 test events and test them directly from the Lambda console. One thing to note is that test events are considered requests. So if you are past the free tier allocation, test events would be charged to you or billed to your account. So we're going to have one little simple test and create. There you go. And so now we have this test configuration. If we had other saved tests, we could select which one we want. We just go ahead and hit test. It says execution results exceeded. And in the details, you can see our response where we had this nice hello world message, which is perfect. Exactly what we expected. You see the duration took 2 milliseconds here. So as I mentioned previously, that in the pricing, that the duration is billed in increments of 100 milliseconds. You can see that here, right? So although we only ran for 2 milliseconds, they billed us for 100 milliseconds. So 10th of a second granularity. And we had 128 megabytes of memory configured. We used a maximum of 37. Most of that, in fact, probably all of that, was probably the Python interpreter. So, like many other services, there is a monitoring tab here that you can use to see the CloudWatch metrics that were collected for this Lambda function. And you see things like invocations, right? So we have one invocation, the duration shows you minimum, average, and maximum. Those are all the same right now. And number of errors and availability that were available. And a few other things that we're not going to touch on. And you can configure that based on a time window. And just like a lot of the other services, it's just a nice way to get a quick look at how your service is operating, whether it's operating correctly or not. So that is the end of our hands-on demo. Just to give you an idea of a very simple Lambda function that will just to give you a sense of what the console looks like. Next thing we're going to do is the sample application. And we're going to go back to this use case where a photograph is taken, you upload it to an S3 bucket, and you run image resizing code. So before we do that, we're going to go back, and this is what this resizer function is doing. I'm going to show you what it looks like first. This example is taken from the AWS the AWS tutorial for Lambda. So if you wanted to get a sense of what this looks like, you can definitely do that. And all the code that is used in this example is taken from that tutorial. So if you want to try this for yourself, you absolutely can. So the objective, what we want to do here is I have two buckets here of AWS Lambda, Lambda buckets, S3 buckets. One called JWallace Lambda Images and JWallace Lambda Images Resized. So how we want this to work is we want to be able to put images, specifically JPEGs, into the JWallace Lambda Images bucket. And anytime a image is put into this bucket, we want our Lambda function to be triggered and automatically resize the image and place it in this target bucket, the JWallace Lambda Images Resized. So that's what we want to do at the end result of this. So you can see here, I've already configured our function with some code that was again taken from the tutorial. You'll notice that this actually interacts with AWS S3 via the AWS library in JavaScript. And this is going to run on the Node.js runtime. For our settings, we've configured our timeout for 30 seconds just because JavaScript can run a little bit slow when we're doing some image processing. So we want to give it ample time to complete, especially if there's a very large image that we're processing. And we've configured our function with 1024 megabytes. Additionally, we have in our execution role, we selected a specific Lambda S3 role that I created earlier, and this role has the capability of executing Lambda functions and talking to Amazon S3. So it has access to S3 and has access to our Lambda function, which is exactly what we need to be able to accomplish the task we set out for. So I'm not going to run through the code. Feel free to take a look at it more closely from the Amazon Lambda tutorial if you would like. And right now you'll notice that I removed the S3 trigger because I want to show a process of how to configure a trigger, which we didn't see in the last in the hands-on demo. So to start, we're going to put an image in our bucket. Right, so there's no images here. So I'm going to add a file, and I'm going to use a nice picture of this big Flyers fan, big hockey fan. Flyers introduced this new horrendous mascot this year. His name's Gritty. So we're going to resize this, some images of Gritty. So we're going to upload a picture, this photo of Gritty. There we go, uploaded. Now if we go back, we will see that there has not been a resized image created yet, and that's because we have not configured the the trigger to trigger from S3. Before we do that, I want to show that we can manually invoke from the AWS command line our function with a specific configuration. So we can ask it to directly grab the image of Gritty that we just uploaded and resize it. So this is the command we're going to run. But before we do that, I just want to show the input file that we're going to use here. So this is a request. This is the typical input that S3 would generate for its trigger, and that our Lambda function would consume. And you can see that it has configured the source bucket, this JWallace Lambda images, and we've given it the specific object. This is the record that is an object created record. So when we configure our Lambda function, we want it to send any object created message to our Lambda function. So our Lambda function is consuming the object created message from S3. In this case, we're using this as a test example, and if we run this, just stepping through this command really quick, we're calling, oh, that's not the one we want, there you go, calling invoke, and we're giving the function name. This goes back to the fact that our Lambda function is called resizer. The invocation type, event, that just means that an event was triggered, and then we're giving it this payload, which is that input file that we just looked at, and this is what will be sent to the Lambda function. So we have no unsafe changes, so we're going to go ahead and invoke this. Oops, I need the output file. There we go. Alright, so it returns us a status code. Now, because our Lambda function doesn't actually return any output, if you look at the output of this file, there's nothing there. That's just because our Lambda function doesn't return any data to the caller besides its status. It doesn't return a body, just returns that status code. But it does have a side effect, right? So now if we go back to our JWallace Lambda images resized, see that we have this nice resized dashgrid picture. And if you look, significantly smaller than the original. So that's the resized. And if we go to the original, see it's much larger. So we've now resized that image. So that's great. We're able to invoke that from the command line, but we want it to be triggered from any time something is uploaded. So in our designer, our Lambda function designer, we're going to select an S3 bucket trigger. And you'll notice it says that we need to configure this. So we get to select the source bucket, the bucket that's going to generate the trigger, and we want that to be that AWS Lambda images. You can choose the event type, and there are some pre-populated types here. In our case, we want all times an object is created. You have the opportunity to, or the option to specify a prefix, so only things that follow the prefix will be triggered. And you also do a suffix, and in our case, we're going to use that to our advantage to just resize JPEGs. And we're going to enable the trigger right now. Instead of waiting to test it, we just tested it via the command line, so we're ready to enable it. So we'll go ahead and add that. Notice we have unsaved changes, so we'll save it. Perfect. And you see that here it will then detail, now details the triggers that we have configured. And you could configure more than one if you would like to. Okay. So now let's test it. Go back to our source bucket. I want to upload a new picture. I want to do Gritty 2, another great picture of him. Horrifying and orange. And it's uploaded. And just to take a look, see the size of this, another nice large picture. And now our Lambda function should have been automatically invoked. So if we go to the Lambda images resized, we now have automatically a resized gritty2.jpg image. And if you open it up, nice and small. And to show that in fact it was executed when we did that, you can go look at the CloudWatch metrics and look at the number of invocations, excuse me. All right, so we are at several invocations. So we have the 2 that I did earlier when I tested. We have one right there and another one right there. So that was the invocations. And you can see that we have some actual statistics on the duration. It's looking like it's taking about half a second, maybe at max a second to actually do this duration. So that concludes the sample application. So we'll move into the summary now. So in summary, AWS Lambda is a serverless compute platform as a service offering that executes code in response to configurable triggers. It's billed by a number of requests and duration of execution, and that duration price is scaled by the amount of memory used. It has continuous scaling, meaning that your Lambda function runs once per invocation, and you don't have to worry about scaling instances that are hosting your application because Lambda completely abstracts away the instances from you. You focus purely on the code. And lastly, I just wanted to highlight that some of the competing services or comparable services in other cloud providers, those would be Google Cloud Functions from the Google Cloud Platform, and Microsoft Azure Functions. Those are the two cloud offerings. But in addition, this idea of a serverless architecture has become fairly common, and there are a bunch of different products that are out there now. Oracle FN Project, IBM OpenWhisk, and Nucleo are three projects that are open source and are or could be hosted in an open source cloud platform. And that concludes the presentation, and thank you for listening.